Hope you all are doing okay and had a great break. So before you guys left, we had done section 1, and we had learned about these charges here, which I have written up here by the periodic table. You should already have those on there because you were here for section 1. So we have positive charges because elements have lost negative electrons. We get negative charges if elements gain negative electrons. So once they do that, once they give and take electrons, they become charged. And we know from that song I showed you in class, Paula Abdul, that opposites attract. So once they become charged, they want to stick together. It's almost like magnets. You have your positive and negative ends. They attract and they stick together. Same thing with these atoms. All right, so we're going to now look at that and kind of take it a step further and really get to know like how these things are going to combine, what's going to happen. So the first thing we're going to do is we're going to watch this guy named Tyler. He does some really good videos. There's some good visuals. I like the visuals that he's able to do. So we're going to watch Tyler explain how sodium chloride bonds together, and we're going to write down the steps he has in this video below. So as he's going through the video, I'm going to pause it and we're going to write down these steps. All right, so let me go ahead and clear out that ink layer. And I'm going to click here. I'm going to pause.
Good grammar and spelling.
I'm going to go back and I'm going to raise this up. So we're going to be writing in here the rule and the example.
Are important. But if you want to write essays that inspire, messages that forge brighter connections, and emails that get the job done, you need to think about more than just grammar and spelling.
This video is an introduction to ionic bonds and ionic bonding. Don't know anything about these things, or you feel a little bit rusty? It's no big deal, because we're going to start from scratch. So, ionic bonds are one type of chemical bond. Chemical bonds are like glue that holds atoms together. Okay, like here are two atoms that are bonded together, they're connected, they're glued. Now, ionic bonds are the type of chemical bond that hold together metal atoms with non-metal atoms. Okay, so if you look at a periodic...
Okay, this is super important, guys, because we're doing just ionic right now in this section, but eventually we'll do just covalent, but then we'll mix the two. And you're going to have to figure out, is this ionic or is this covalent? And so you're going to be able to tell that apart by what two elements do you have? Do you have a metal and a non-metal? Then it's ionic.
Table. There's this big, thick staircase over on this side. And this staircase separates the metals, which are all the elements on this side, from the non-metals, which are most of the elements on this side. So whenever we have a chemical that has a metal connected to a non-metal, that's held together by ionic bonds. So some examples are silver chloride, magnesium iodide, or aluminum oxide. Each one of these chemicals have a metal, this one, or this one from this side of the periodic table, with a non-metal, this one, or this one from this side. So ionic bonds in all these because there are metals and non-metals connected together. Okay, so now we're going to talk a little bit more about the how and why that's going on with the bonding here, right? It's like, how do these atoms actually connect together? What's holding them? That's what we're going to talk about next. Okay, so to learn more about ionic bonds, we are going to focus on a chemical called sodium chloride. Sodium chloride is a fancy scientific name for table salt. It's the stuff that you put on your food. So sodium chloride is made of two types of atoms. We got sodium. Here's its symbol from the periodic table, and here is a sodium atom right here. And sodium chloride is also made of chlorine or chloride. I'll tell you what the difference between those is in a minute, but you don't have to worry about it right now. And here is here's a chlorine atom. Now, sodium chloride happens when these two atoms come together, when they're glued together by ionic bonds. But the atoms that I have right here, they're not glued together. They're just kicking it over here. They have nothing to do with each other. So I want to talk about what happens to get these separate atoms connected and glued together, like these. How we go from this to this. I'm going to tell you the kicker. I'm going to tell you the end of the story now so you can follow it through as we talk. The reason why these two atoms are connected is because they end up getting electrical charges. Okay, this atom is going to end up getting a negative charge, and this atom is going to end up getting a positive charge. What do oppositely charged things like to do? They like to attract. And so because these things get different electrical charges, they are going to be held together by those different charges attracting. Okay, so let's look at the steps that we have to take to go from this to this. The first step is pretty much what I got right here. We're starting with two separate atoms that aren't connected. We got the metal atom, the sodium here, and the non-metal atom, the chlorine, over here. Now the first thing that happens on the road to an ionic bond is that the sodium atom.
Okay, so let's go ahead and let's write our first step down. Okay, the first step is we're going to start with separate atoms. So you get a metal and a non-metal. Okay, so we have our sodium and our chlorine. All right, let's go back and get step 2.
Gives one of its electrons to the chlorine atom. Here's the electron moving between the two of them from the sodium to the chlorine. Now this electron,
So I stopped the first one a little too late, so we're going to go ahead and write our second one down. Sodium gives an electron, so I'm just going to do the E with the negative, to chlorine. So I'm just going to draw this circle. And I'm going to draw that. Sodium's giving that to chlorine.
electron moving will change the charges of these two atoms. Okay? That's what happens in the next step. Sodium gives away one of its electrons to the chlorine, so it loses one electron. It has one fewer electron, and that's going to give it a positive charge because it lost an electron. But chlorine...
All right, so I'm going to pause it there. Let's write this down. Atoms get a charge. And become what we call ions. Before they were just atoms. I have an atom of sodium. Well, when it loses an electron and becomes Na+, it's now a sodium ion. So what we get is we get sodium, who has a plus. It lost one electron. We get chlorine, which is now a negative. It gained one electron. And when this happens, I think he's getting ready to say this, it was chlorine. It was chlorine before this happened. As soon as this happens, it becomes chloride. It is now chloride. Sodium does not become sodide or anything like that. The positive never changes. The positive ion, its name stays the same. Now the negative ion, we will change the ending to IDE. So it just, when you're saying them, that's where we get like this carbon monoxide, carbon dioxide, all that good stuff.
gained one of the electrons from sodium. So it's going to become negative. It's going to get a negative charge because of that extra electron. So now, these two atoms take on electrical charges. And what do we call atoms that have charges? We call them ions. This one's a positive ion, sodium becomes positive, chlorine becomes negative. Now here's where the difference between chlorine and chloride comes. Chlorine is what we call the chlorine atom when it's neutral. So up here, this non-metal atom, chlorine, just hanging out here, is chlorine, zero charge. But down here, after it's received one of the electrons from sodium, it gets a negative charge. It becomes a negative ion. And now we change its name just a little bit. We call it chloride. So it's the same atom, chlorine and chloride. They're the same atom. It's just chlorine is the version of chlorine with a neutral charge, 0 charge, and chloride is the version of chlorine that just has a 1- charge. And it got that 1- charge because sodium gave one of its electrons to chlorine, turning it into the negative chloride. Now people often ask, why does sodium give its electron to chlorine? We'll talk about that in the next video. It's a great question. But anyway, a transfer of electrons takes place between these atoms, giving this one a positive charge and this one a negative charge. And what do opposite charges like to do? They like to stick together. And so this...
All right, so that's the last step. We're going to stop that there. So the last step are ions now have opposite charges so they stick together. All right, so we get this positive connected to that negative. All right, so that's the steps of how this happens. Now this is a very simple one. It's just sodium and chlorine. They're each, one's losing one, one's gaining one. So we can see where they're gonna get a little bit more complex. So let's go ahead and move on and look at that. Common rules for ionic formulas. And remember, ionic means a metal and a non-metal. Don't forget that. Number one, it consists of positive and negative charged atoms. Number two, and this is a huge one, it will be neutral. So the positive and negatives are going to cancel each other out. So is neutral. Super important. It has a charge balance, which is really the same thing as saying it's neutral. So has a charge balance. So what that means is that your positive is equal to your negative. So it's neutral, right? If I have a +2, I have a -2. And the last one, and this is really important also, we use subscripts to indicate the number of ions needed to get that charge balance. So that's where we see H2O. H2O, we use that little subscript there to tell you, hey, you need 2 hydrogens to make this work. Now H2O is not an ionic bond, but any bond is going to use these subscripts to tell you how many you need. All right, so let's try what Tyler did with sodium and fluorine. So this is going to be very similar because look where fluorine's at on the periodic table. It's in the same column that chlorine is in. So it's going to look pretty much the same. So what I'm going to do is I'm going to put my 1 electron here. I'm just looking, remember it's all about the valence electrons. How many valence electrons do you have? Because that's what we're trying to do, is we're trying to get these things stable and full. So fluorine has 7. If you looked up above, fluorine has 7 valence electrons. So what happens is that electron's going to go over to fluorine. So what we get is we get Na, and now we have fluorine like this. It gave an electron. So what happens is we lost this negative electron, so we're going to get a positive, and we're going to get a negative. So what this all shows me is that I need 1 sodium for every fluorine. Now they have these charges on them. Opposites attract. That's what's holding them together right now. If this transfer of electrons doesn't happen, then they're not charged and they're not going to attract each other. All right, so let's try it with one that is going to have some subscripts. All right, so we have magnesium and chlorine have a formula of MgCl2. Write down the Lewis dot structure, which remember that is valence electron for 1 magnesium and 2 chlorine. So I'm going to take 1 magnesium, because that's what it tells me I have, 1. And I'm going to look and see how many valence electrons does magnesium have. It has 2. I'm going to do these in different colors. All right, and it says to do 2 chlorines. So I'm going to put chlorine here and here. How many valence electrons? It has 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So you can see what is going to happen here, how the electrons are going to move. You're going to have this electron go right here, and now chlorine is happy, but magnesium's not happy. That's why it needs another chlorine. It needs 2 chlorines to become stable. If it just has 1, it's not going to do it. It wants to get rid of both of the electrons, okay? It doesn't want to get rid of just 1. So it needs 2 chlorines there in order for this reaction to happen. All right, so now they're both stable. We have a magnesium that is a +2. I have 2 chlorines, which are -1, and they will connect. They will connect because of these opposites attract. All right, let's clear the ink. Let's do one more here. All right, we're gonna writing Lewis dot structures every time can become tiresome. Let's write the formula for Na and nitrogen based off of the charges on the periodic table. So remember, you guys have these charges. So I'm gonna write down sodium and look above sodium on that column. How many electrons will it lose? Well, it's got a +1 charge. It's gonna lose 1 electron. Now let's look at nitrogen. Nitrogen, if you look at it, it has a -3 above it because it wants to gain 3 electrons. It's not happy if it just gains 1. It wants 3. So you have to ask yourself, how many sodiums does nitrogen want then? It doesn't want just 1. So I'm going to write this out because some of you right away will be like, oh, it needs 3. All right? So I'm going to write this out for you. There's 1 sodium, and here's 1 nitrogen. So to get these to cancel out, I have to have 3 sodiums. Now look, my charge is +3. This is -3, and they cancel out and they're good. So this, when you write this, this would become Na3, because that's what that subscript's telling me, how many sodiums I need, and then just 1 N, Na3N. All right, and that's how you're going to do that. Now, another way to do this is to crisscross these. So I'm just going to do this real quick. So because you'll see a lot of these problems, and you don't want to have to write this out every time. And one quick way to do this is to go, okay, sodium has a +1 charge, nitrogen has a -3. I am simply going to bring that 3. I'm not going to look at signs. I don't want the negative. I'm just going to crisscross this, and it's going to give me Na3N. All right, that is one very simple, quick way to do this. Just ignore the negative signs. All right, so let's look at the learning check here. Write the correct formula for the ionic compounds formed by the following ions. So we have sodium and sulfur. So I'm going to do what I just did here. I've got sodium, and I'm going to look at the charge. And right away, like, I know this is all ionic because this whole section is ionic, but check it out. Sodium is a metal, sulfur is on the non-metal side, so yes, they're ionic. Sodium has a +1 charge. Look sulfur up on the periodic table. If you look above, it has a -2 charge. Now, if I just use this crisscross method, I know that sodium, I'm going to cross that 2, and then sulfur is going to get that 1. Now, you can put a 1. You do not have to. I never put the 1. I just put Na2S. You assume that there's 1 there if you put it. All right? Now, if you're struggling with what I am doing with this crisscross, just remember, if sodium is a +1 and sulfur is -2, I need to get these charges to cancel out. So now look, +2, -2. All right, so let's try B, aluminum and chlorine. So aluminum, if you look at its charge above, it is a +3. Chlorine, look at its charge, it is a -1. So if you crisscross these, that 3 is going to go to the chlorine, that 1 goes to the aluminum. So it becomes Al1, or just leave it, Al, and then Cl3.
Teachers and staff, food is ready by front main entrance. Come on down.
So A is your answer on that. All right. C, we have magnesium, which is a +2, and we have nitrogen, which is a -3. So if you're looking at this, I'm going to erase some of this. I'm going to have crisscross that 2 to magnesium, or that 2 to nitrogen, and that 3 to magnesium. So Mg3 N2. If you want to look at how I did this, I have Mg, which is a +2, and I have nitrogen, which is a -3. So I'm like, I have a more negative than positive, so I'm going to add positive. Well, now I have more positive than negative, so I'm going to add my negative. So I have a -6 and a +4, so I need to add another magnesium. Now look, I've got a +6, and I have a -6. All right, let me know if you need any help with that, and I will get back to you. Have a great day.